So it is the cosine one. So when we see cosine, let me underline it here. Cosine, sine, like that. Come on back. Here's the main formulas we're using, right? Cosine, sine. So we go, oh, okay, so it came from this, didn't it? Let's first identify the AB. That's the first thing they want us to look at. So let's look here. See the AB, or they're calling it alpha, beta, whatever, same thing. 73.28 degrees. That's the first thing. They're just having you identify the pieces. So 73 and 28, those are the two little pieces there. Next, they're going to say, okay, you've identified the A and the B. Now, I forget, what do they, let me enter those. All right, are we good so far? So they identify the A and the B. And then they say, okay, this is equal to the cosine of what?
A minus B.
Yeah. So as soon as you identify it, as soon as you look back here and you go, oh, that's this cosine formula. Remember now, the sign in the middle, going back to here, is always the opposite. Cosine does opposite. Sine does same. So this one's a cosine. So whatever we find here, so I'm going to write 73 and 28 in one cosine. So you see the formula. You see the pattern. Math is all about patterns. It's one cosine with two angles. Becomes two cosines and two sines with those angles. And the opposite sign in the middle, plus in the middle, leads to minus, or vice versa. Opposite sign in the middle. See the pattern? That's what they're always communicating to you in math and science, is a pattern. And your job is to see it, predict it, understand it, describe it, the pattern. Getting better and better with the pattern. The pattern is one cosine, two angles, leads to equals, is the same as two cosines, two sines, and opposite sign in the middle, huh? So we go back and go, okay, I can do that pattern. So two cosines, two sines is the same as one cosine with those two angles and opposite signs. So plus here leads to minus there. Good? Like Pauline says, though, they were telling me right there. All right, and then subtract them. Whatever that is. I don't know, 53, is it 45? Yeah, it's 45, huh? Cosine 45 degrees. Good? So that's what they want in part two. They want you to say, hey, that's cosine 45 degrees. Based on the pattern, two cosines, one sine is, two cosines, two sines is one cosine. Those subtracted, opposite sign in the middle. And then, what's cosine of 45? Go to the unit circle. Cosine 45, cosine root 2 over 2. That's the third answer they want. Done. Is that making sense?
So this is to help us solve points that are not on the unit circle.
Yeah, that's what we can do it for, and some other special things too. We'll see some other ways in which it works. Yeah, it's just to learn these formulas forward and backwards because they can do some special things. Yeah. All right, well, we need a break. All right, so here's number 3. In fact, let me just, it's kind of confusing. So number 3 basically says they want sine of alpha plus beta over cosine. Sine of, well, let's make it A and B. Sine A plus B cosine. Right, okay. So they basically want me to take this. We're basically going to do something with this fraction. Let me show you. So I'm going to take that numerator, and they want me to simplify that thing. Okay. So that numerator right there, that's one of our patterns. What do I mean? Remember, you have one sine, two angles added. Let's go back. Here it is. One sine, two angles added. Let's follow the yellow brick road. Just follow the pattern. You'll get there. It's sine, cosine, cosine, sine. Right? That's the pattern. See the pattern I'm going to follow? Follow that formula. Sine of one sine, two angles added becomes sine, becomes four things, doesn't it? Sine, cosine, cosine, sine. So let's do that. So I'm going to go, okay, this top is sine, cosine, cosine, sine.
Does this have to do with the trig identity that we've been...
Yeah, it's going to be like a special identity. So is that good? And then just the A, B, A, B, A, B, A, B. And what sign goes in the middle?
The same.
Yeah, for sine, the plus or minus in the middle is always the same. For cosine, it's always opposite, huh? So plus in the middle, plus in the middle. Good so far? So there's step one. Step two, what they ask you to do. Yeah, because Pauline's right. We're going to a special theorem. We're going to get like a special result here. On step two, they want you to separate things. We did this in one of the proofs today, one of those identities. They want you to separate it. So what do they mean? Do you guys notice the top? How many, let's see if you're getting the lingo. How many terms in the numerator up here? How many terms up here?
2.
2 terms, yeah. It's, this is one term, and these two are, remember, terms are things separated by pluses and minuses, aren't they? So there's 2 terms on the top. Why is that such a big deal? Because that tells you the structure. You want to make this sine A, cosine B, right? That one goes there, and this one goes here. Cosine A, sine B. Did you see that?
Did you just get rid of that numerator, like, completely?
I just separated it. So what I did, let me write it with simple numbers. It's like I had 1 plus 2 over 3, and I made it 1/3 plus 2/3. Do you get the idea? I had one thing on the bottom, here it is and here it is, like 1, 3 on the bottom, here it is and here it is. And I took this part of it and went left, this part of it and went right.
So, yeah, so you got rid of the sine of A plus B, but you still left the cosine of A cosine.
This right here?
Yeah.
Yeah, that I just did the formula there.
Oh, okay.
Right? Because that's exactly what the formula says, like, right? Let's look back at the formula. The formula says if you have one sine, it equals, it can be replaced with, a sine and cosine, 4 things, huh? One sine, see the pattern that
Yeah.
formula is putting forward?
Yeah.
One sine can be replaced with those 4 things. So that's exactly what I did. I took that one sine on the top and replaced it with those 4 things on that. And so then we come down to here. And I just separated over a common denominator. Does that make sense? How I separated those two over the same denominator? Like that. And now, do you see what I can do? How I can simplify? How can I simplify this first one? Can I cancel those guys?
Yeah.
Or not?
Yes.
Is that okay?
Yes.
Are they glued?
No.
No. It's fine. Shopping at Save Mart. It's not Costco. There's no plus or minus between them. There's no glue. You can buy just one. That's fine. And then what are you left with? Sine of A over cosine of A. What's that? What is sine of A over cosine of A?
Tangent.
Tangent of A. Good. Remember sine over cosine of the same letter is tangent. And here the cosines cancel. And what is sine of B over cosine of B? Tangent of B. We're done. They wanted us to do that. I know it probably doesn't mean a lot to you, but we just proved that this leads to that. Questions on that one? Is that okay? No questions? All right, we better go on. There's a couple. So let's try this one. Sine 60 minus 45. So they want you to work this one out. Sine of 60 minus 45. Okay. So try that one. So so they want me to use the formula. So which formula are we going to use? I've got it there on the board for you, and then it's probably on your paper. So 1 sine, 2 angles subtracted, right? This section is all about 1 sine or 1 cosine. We're going to get to tangent. With 2 angles added or subtracted, sum or difference formulas. You get 2 angles added or subtracted in a sine, cosine, or in a minute, tangent. What can you do? Well, it's going to become 4 things, isn't it? Right? Look at the pattern. It's right here on the board. Look at the sine. 1 sine becomes 4 things. So follow the yellow brick road. Follow the pattern there. You're doing good. So this will be sine, cosine, cosine, sine. We good? Sine, cosine, cosine, sine. $60, $45, $60, $45. Sine in the middle.
That's a minus.
And it stays the same for sine, doesn't it? So for the sine formula, the sine of 2 angles added or subtracted, the plus or minus in the middle, you just keep it the same. You guys going to be able to finish both these sections over 4th of July?
Yeah, absolutely.
Pauline says yes, Jose says no. Not going to happen.
So you don't put it in the order like the way on the unit circle where sine is second number, which would be 45, and cosine would be 60?
So no, I'm not doing any of that. I'm just literally following this yellow brick road. Just exactly this pattern, which says sine, cosine, cosine, sine. So this is a special formula for adding 2 angles or subtracting them. Different than any of the other things we did. So this is true when you add or subtract 2 angles in one sine or cosine. It's just like that. Okay, so now we just find the 4 pieces. So sine of 60, now we go to the unit circle. So where's my unit circle? There it is. So sine, so 60 degrees, cosine sine, there it is, root 3 over 2, right? So this one becomes
Pretty much, yeah.
root 3 over 2 times cosine 45, 45 cosine sine, root 2 over 2, minus cosine 60, it's a half, sine 45, root 2 over 2. Is that good to there? And now we just multiply them together, right? So root 3 times root 2 is root 6 over 4. It's a lot like the other one, huh? One root 2 is just 1 root 2 over 4. And then you just put those together, root 6 minus root 2 over 4. I can't subtract those on the top, so it just stays that way, huh?
I'm just going to add 15 degrees on my...
Yeah, you could just add an
circle and
entry
just-
of 15 degrees. Huh?
Because now we have both the cosine and the sine.
For 15. Did they come out the same?
No?
No, different.
No, they're different, because
Of
one
course,
was
that makes
cosine and
sense.
one was sine.
Yeah, silly question. You're right. Good? Questions I can answer on that? Yeah, so that is the sine of 15. We have a special value now for sine of 15. Huh?
Is there a shortcut now?
No.
No,
Not yet.
not that I know of.
So that's the shortcut.
Okay, so they're saying sine at 225. Is that, let's go to the unit circle. It's 225 on my unit circle.
Yes.
Oh, yeah. What's the deal here? Don't I just grab, this is cosine sine. Boom, there's the sine at 225. Negative root 2 over 2. Now, are they going to take that answer?
Try it.
One more of this.
I mean, it's right.
Use one or more of the 6 sum and difference to find the exact value. Sine 2. So let's change the game. How about sine 75? Now that one's not on my unit circle, right? 75 degrees is not there. If you go to the unit circle looking for 75, here's 60, here's 90, 75 is missing. It's not there. So how am I going to do 75?
Are we going to break it up to 45 and 30?
Exactly. Break it up to a couple that we know. 45 and 30 is the best way to go, I think. Yeah. I'm not even sure what else you could do. So yeah, so that's right.
Would be sine
So it's going to be sine of 45
plus 30.
plus 30, huh? And now, how do you figure out sine of 45 plus 30? You have to use the special. You can't just do sine of 45, because, you know, you might think, well, can't I just do sine of 45, get an answer, sine of 30, get an answer, and add them together? No, it's not that simple. You got to use that whole fancy formula. It's not just distribution, in other words, like we talked about a little bit, huh? Because that's not multiplication. That's a special toaster called sine. It does special things, and here's the pattern. There's the yellow brick road we got to follow on that. Yeah?
Does it matter what number we put first?
No, good question, Manveer. Either way, 30, 45, 45, 30, the order doesn't matter at all. So now I'm going to follow the pattern that we learned, and this section is all about using this formula, which is right here. No, that's not it. Right there. So the sine of 2 angles added, one sine is sine, cosine, cosine, sine, huh? So let's do that. So, in fact, I'm going to bring it down so I don't run out of room. Sine, cosine, cosine, sine. Put in the angles. 45, 30, 45, 30. You guys tracking with me? $45, 30, 45, 30. And what plus or minus goes in the middle when you use the sine formula? Same. Sine always uses the same in the middle. Cosine always uses the opposite. Plus, and then you just go to the unit circle, find those different pieces. If you go to the unit circle, you'll find sine 45 is root 2 over 2. Cosine 30 is root 3 over 2. Cosine 45 is root 2 over 2. Sine 30 is a half. Good? And then just multiply them together. So multiply the tops, root 6 over 4. Multiply together, root 2 over 4. That looks familiar. Root 6 plus root 2 over 4.
So what if you get an angle of like 72?
Can't do it. Yeah, that's calculator.
Calculator.
Yeah, so we can't do every angle, huh? But we can do more than we could before.
Any increments of 5 you could do?
I don't think so. Only certain ones.
Really? Because it goes with
So
45,
that's-
60, and 30.
So how would you get 35, for example?
All right, it's not on there, right?
Yeah.
Yeah.
So is that going to be the same as our cosine one that we did with would root 2 plus root 6 over 4
Yeah.
be the same?
Yeah, same thing. The order doesn't right. The order of adding things never matters. Yes, that's the same thing.
So it's gonna
So the
be-
cosine of 15 is the same as the sine of 75. No surprise. What's 75 plus 15? 90 degrees. Those are complementary functions. If the angles add to 90, the sine and the cosine will be the same. That's why it's sine and cosine. Yeah. It's all coming together for you, right? All these different trig rules?
Makes sense.
Sort of. Okay, so they're asking tangent. I'm going to give you a tangent formula. Here we go. The tangent of A plus B is, I don't know. I never memorized this one. It's,
Tangent A, tangent B over 1 minus tangent B.
thank you. Let me see. I always need to see it. I'm a visual person. So, what section are we in? 3.1, 3.2. Show 3.2. There we go. Yeah, so tangent A plus B is tangent A plus tangent B over 1 minus tangent A times tangent B. Yeah. Okay, so notice the tangent. So this is the yellow brick road, the pattern for when you have the tangent of 2 angles added. Again, you can't just distribute, right? It doesn't just say, oh, it's just tangent A plus tangent B. That's just not true. It's that instead. Everybody see what I'm saying there? I hope that's making sense. Because I used to think, when I was a trig student, I didn't get it. I looked at things like tangent A plus B, and I thought, well, that's just tangent A plus tangent B. That's not true. Or they would have said that. That'd be way easier. That's not true. Everybody see that? You can't just distribute because it's not multiplication. You got to do this instead.
Because it's a function.
It's a function. It does a special thing. That's what they're saying. You getting that? If you're getting that, you're way ahead of where I was at trig. Make sense? Does a special thing. You can't just distribute. What do? This whole big fancy special thing. Okay, so let me help you observe the pattern. Notice the pattern. Whatever is in the middle here, it's the same on the top, but it's opposite on the bottom, isn't it? Same on the top, opposite on the bottom. So when you do the tangent formula, it's the same sign on the top, but opposite sign on the bottom when you do that. So we got to do that whole tangent thing now.
Is it only the first minus or the second minus? Or what's this? That's not a minus, it's multiplication, huh?
Yeah,
Tangent A to B?
yeah.
Right here? That's multiplication?
So we leave that there. It's always gonna be multiplied.
Yeah. So we've got. So 2 angles added is tangent A plus tangent B over 1 minus tangent A times tangent B. The sign in the middle is the same on the top, and it is opposite on the bottom. Yeah, all right. So with that in mind, let's try this problem. So tangent 2 angles added. Let's follow the yellow brick road pattern. It's supposed to go 1. No, I already forgot. No, tangent A, tangent B on the top. Okay, so tangent of the first one plus tangent of the second one all over 1 minus tangent of the first one
This is gonna be,
times tangent
this is gonna be a bit.
of the second one. Good to there? So I just follow the pattern. Pattern says if you have tangent of one tangent, 2 angles added. So this is all about sine, cosine, and tangent, how you add or subtract 2 angles in one sine, cosine, or tangent. For tangent, what you do is that big old formula. Now, to do that, yeah, Pauline's right. It's going to be a lot of work. We got to go find tangent of pi over 6 first and tangent of 3 pi over 4.
That's a lot of fractions.
Yeah. So let's go over here on the side and say, hey, what is tangent of pi over 6? How do you do tangent? What is tangent? Sine over cosine. So it's going to be sine of pi over 6 over cosine pi over 6, isn't it? Remember tangent sine over cosine? Okay, and let's go to the unit circle. What is sine of pi over 6? And what's cosine of pi over 6? Go to pi over 6. Pi over 6. Cosine sine. Cosine's root 3 over 2. Sine's a half. So sine is a half. Cosine's root 3 over 2. Good. And so, just cancel those 2's. And so, tangent of pi over 6 is 1 over root 3. Now, we're not supposed to leave roots in the bottom, but let me just leave it for now. We've got a lot of other mess to deal with. We'll get to it eventually. I'm going to leave it for now. 1 over root 3. Good so far? So I found tangent of pi over 6 there by sine over cosine from the unit circle. How we doing? I was wondering this last half an hour if I still have your attention. I start fading into the Charlie Brown teacher, the wah wah wah. Is it all good?
So the first tangent.
Good. I remember one of the first years I was teaching, I learned about that. I was teaching a class up at Stockton, Delta College, and passed out my key on accident. I was doing a lab. I passed out at the beginning of the class, and my key was in the middle of it with all red writing all over it. I accidentally passed it out in the middle of the pile, and I stopped class, and I said, hey, I accidentally passed out my key. Instead of being blank, it's got red writing all over it. Somebody got my key, I made a big deal for like 5 minutes trying to find my key. And Nobody had it. I went, all right, whatever, I'll just solve them as we go. It was like a lab thing I was working on over there. I said, I'll just solve them as we go. And about half an hour later, young lady from the back of the room raises her hand. Says, there's something funny all over mine. She holds it up. It's got the red writing all over it. I went, oh, yeah, that's my key. I went back, got it, gave her a blank one. And I remember going back to my office. I didn't say anything to embarrass her at the time, but I went back to my office later, and I thought, wow. I mean, what was going on? I mean, I understand not hanging on every word I'm saying, of course, and a little bit of drifting, thinking about different things. Oh, I got to get this done today or that, and making little notes, But, I mean, I made a huge deal for 5 minutes. Stopped class. Who's got my key? Who's got my key? Red writing all over it. What was going on in her brain? She was like out of the classroom. I mean, really out. As I remember thinking that day, wow, they're not always hanging on every. I mean, I'm doing the Charlie Brown teacher, the wah wah wah. I was doing wah wah wah. So anyway, I'm always nervous. I'm doing wah wah wah. I learned that day that I need to repeat if I want to communicate clearly. So good so far. Tangent pi over 6. Now we're also going to need. That's going to be one piece of the puzzle. We're also going to need tangent 3 pi over 4, aren't we? So let's go get our hands on tangent 3 pi over 4. So tangent 3 pi over 4 is sine over cosine again. Sine 3 pi over 4 over cosine 3 pi over 4. Let's go to the unit circle. 3 pi over 4. Where's that? Where's 3? There's my unit circle. 3 pi over 4 right here. Cosine, sine. They're the same. Cosine is negative root 2 over 2. You can barely see that negative sign. Negative root 2 over 2 and sine's positive. So, where are we? So, cosine is negative root 2 over 2. Sine is positive root 2 over 2. So, what's tangent then of 3 pi over 4? Negative 1. Everybody good? Because positive over negative is negative, and the same thing over itself is 1. Okay, so let's put those back in the puzzle. We got those pieces. So wherever I have tangent pi over 6, I'm going to plug in 1 over root 3. And wherever I've got tangent 3 pi over 4, I'm going to plug in negative 1. Right? We good? So what do we have now? Now we have tangent pi over 6. That's 1 over root 3. Plus tangent 3 pi over 4, negative 1. All over 1 minus tangent pi over 6. 1 over root 3 times tangent 3 pi over 4, negative 1. How are we doing? We good to there? Mm-hmm. So now we got to clean that up. Can't leave it that way, unfortunately. It'd be nice to say, we're done. No, we have like a whole other page of steps to go. This one's pretty hard. You ready? And we haven't got to the really hard ones, those last 3. So this is almost on their level, though. Okay, so now we have to clean that up. First off, on the bottom, negative times negative. Yeah, that's positive. So I'll get to there. Is that good to there? Right here, plus and minus is just minus. And then negative is positive. Good? To there so far. I'm going to take that to a fresh screen because we got some work to do on that thing. So, 1 over root 3, so we're at 1 over root 3 minus 1 over 1 plus 1 over root 3. Okay, now that thing's ugly. It's a mess, huh? That's a complex fraction. It's called, because fractions over fractions. It's a big mess. Now, normally, when we have fractions in the bottom fraction, we just grab them and flip them up, don't we? We can't do that here because of the glue.
You have to simplify.
You see the problem? If this was times, it's always pluses and minuses that cause all the problems. If that was times, I would just grab that thing and flip it up like we've done many times before. We got a fraction on the bottom of a fraction. Just flip it. Because he would be able to move alone. But with the plus sign, he says, don't mess with me. I'm glued to the 1. They're stuck together. So you can't be just grabbing part of it and ripping the glue bond apart. You can't do that. Well, then what do?
Find common denominator.
Common denominator and multiply through by. What is the common denominator? What's the only denominator? Root 3. Right? So what we do is we multiply everybody by root 3. Root 3, root 3, root 3, root 3. Because that's the denominator the two of them have, huh? That makes sense? This one's going to require a lot of cleanup. We're just getting started. This will be the first step. So, why am I doing that? Because I want to make it cleaner, get rid of those extra root 3's. Right, this is really root 3 over 1, so it cancels there. It's root 3 over 1, so it cancels there. So what does that leave me with? 1 minus root 3 over root 3 plus 1, huh? So far so good? It's a little better, isn't it? It's not fractions over fractions anymore. It's much cleaner. Now, why can't I just leave it that way? Why aren't I just like, done, good, there it is, next problem?
You have a root at the bottom.
Roots on the bottom are not allowed. Right, you guys with me? Everybody okay with that last step? Does that make sense? So roots, we can't leave it because we got a root on the bottom. Now, that's not the end of the world. We've dealt with roots on the bottom before, right? We know how to deal with it. You just multiply top and bottom by root 3, right? Whatever's on the bottom, just multiply top and bottom by root 3. What on the bottom of this fraction, looking right here, what on the bottom of that fraction might alert you that this one's going to be a big pain in the behind? The plus sign, like always, throughout algebra. If that was times, I would totally just multiply top and bottom by root 3 and be done in one step. But it's not times. It's plus. And when you have pluses and minuses, everything is hard. It's the first time we've had a root along with a plus or minus in the bottom stuck together. So you had that in algebra. And you remember perfectly what to do about it, right? Anybody remember? What do you do when you got a root and a plus or minus in the denominator? There's a special, it's even got its own name, the action you take. When a root and plus or minus in the denom, what do? You multiply top and bottom, not just by the root 3. That'd be nice if there was
But by the whole equation, right?
almost. And nobody remembers? Not even one? You've all had algebra? Nobody remembers? By the conjugate, which is opposite sign in the middle. Opposite, so you multiply by root 3 minus 1 over root 3 minus. You use the whole thing, but opposite sign in the middle. That doesn't look familiar at all?
Nope.
None of you are like, oh yeah, I sort of remember that. No?
Never taught.
Nothing? Never happened?
Never happened.
High school's a long ways away.
Remember the name, but not what it is, huh?
High school's a long
Never
ways
seen that in my
Yeah,
life.
me too. Never seen that in your life? Really?
Never.
How do you get through algebra without ever seeing that?
Made it.
All right. Yeah, so you want to make specific note of that. When you're multiplying, when you get a root and a plus or minus in the bottom, they're stuck together, so it makes sense that you'd have to use the whole thing, huh? Because they're stuck together. But specifically, you got to use opposite sign in the middle. Why? Well, because it'll work. You'll see. You'll see when we carry it out. So in other words, if this originally here, if this had been a minus sign in the beginning on the bottom, I would have used plus over plus. Does that make sense? Whatever sign they have in the bottom, you use the opposite of that, top and bottom. You got to do the same thing, top and bottom. They had plus top and bottom. I'm using minus top and bottom. And now, I'm going to rewrite that. What was that? That was root 3 plus 1. So now we have to FOIL the top and FOIL the bottom. So I got to take this and go boom, boom. Remember foiling? First to both, second to both. Double distributing, basically. First to both, second to both. So what do we get? 1 root 3 minus 1, and then he's done. And now this guy's going to go to both. What's root 3 times root 3? Plane. Are we all good with that? Root 3 times root 3 is plane 3.
Can square cancel out there.
Yeah, right. Yeah, root 3 is root 9 is plane 3. Root 7 is plane 7. You get the idea, right? When you have two of the same in a root, it's 1 out. I always tell my algebra students, 2 for 1 deal. Like shopping at Target, 2 for 1 deal. 2 3s in a root, 1 3 out. 2 7s in the root, 1 7 out. It's like Target 2 for 1 deal. 2 3s for the price of 1 out. Get out of the store. Price of 1. Okay. So keep going. Minus root 3, plane 3, minus 1, minus root 3 times minus 1, 2 minuses, plus root 3. There's the numerator. Okay with those 4 terms? Got to be careful on all your signs. If you want to go higher in math, this is where you got to focus your attention. It's right here. It's all these kind of algebra rules that make or break students in pre-calculus and calculus. It's all their algebra skills or lack thereof. So this is what you want to master if you're going higher. It's not fancy stuff. It's all the algebra rules. So on the bottom, I'm going to FOIL as well. The root 3 goes boom and boom. Root 3 is plane 3. Root 3 times negative 1 is negative 1 root 3. And then he's done, and now the 1 goes to both. Plus 1 root 3 minus 1. Everybody see that? See how I foiled the top and foiled the bottom? Are we all good with that? You okay with that foil? Now, why are we doing all this again? Remember, you want to get a bachelor's degree, so you're taking... No, I don't mean all that. Why are we doing this specific problem? What are we trying to get rid of in the bottom?
The root.
The root. The root. Well, it looks like we still have a root. We didn't get rid of the root in the bottom. Or did we? What do we got here? Minus 1 root 3 plus 1 root 3. Gonzo. Do you see now why we used the opposite sign? Because then you get 1 plus 1 minus, and they drop out. That's how you get rid of the root from the bottom. That's why when we had plus in the bottom, we use minus top and bottom. That's why you use opposite sign. That's why the conjugate works. You use the opposite sign because then you get them to drop out. That's what gets rid of the root from the bottom. So what does this all leave us? On the bottom, it's just 3 minus 1, 2. On the top, it's 1 root 3 and 1 root 3. What's that mean? 2 root 3. You add the numbers in the front. Minus 1 minus 3, minus 4. Ani.
So for the conjugate or whatever, on the bottom, say you didn't have like root 3 plus 1, and you just had root 3.
Yeah.
You,
Just multiply top and bottom by root 3 then. You don't have to do the whole fancy thing.
What if it's like a negative in front of that root?
Doesn't matter. Plus or minus. Signs don't matter. It's when you have 2 things added or subtracted.
Okay.
Yeah, that's what I'm saying. Multiply top and bottom when you have a root and plus or minus. So I really mean plus or minus between 2 things
Okay.
on that. Is that good? Oh, yeah, and then the 2's. I forgot. Cancel the 2's. Root 3 minus 4.
No, you can't do that because there's a minus in
Good. That's illegal.
there.
But we have to do something. We can't leave that answer. That's not right. But let's hold on. That's illegal what I just did. Everybody good with that? Why? Costco says no. This top says I'm a package deal. I'm glued together. You want to cancel me? You buy both sides of the glue bond, not just one side. So does that mean we can also do the other side? Yeah. That's what you have to do. The 2 goes into both of them, not just one of them. It's a glued package. We're buying them both. We're dividing them both by 2. 2 goes into 2 one time. 2 goes into 4 2 times. So it is 1 root 3 minus 2. We're finally done. That's the real answer. 1 root 3 minus 2. Yeah.
What if the 2 numbers are different?
Yes, good question. What if instead that was 2 root 3, say, minus 7 over 2, let's say. Can't do anything. Because that 2 doesn't go into both of them. Remember, it's all or nothing. We would just leave it. We just stop right there. Really good question. So when you have 3 outside numbers like that, they have to all be divisible by the same thing, or you do nothing because of the gluing on the top. Gluing together makes it an all or nothing deal like shopping at Costco. Get the idea? So that 2 went into both these guys. 2 goes into 2 one time, 2 goes into 4 2 times. You're getting all those algebra. You're becoming a master slowly. A master of algebra. This is how you become a master of algebra. If you want to do it at calculus, you need to be somewhat of a master of algebra. Is that good? This coming together for you? Starting to get the hang of these Costco rules and factoring and conjugate. It's really all stuff that technically you're supposed to know coming in the door, but no one ever does. I know. It's algebra stuff. But it's hard to remember it all and to keep it all together. All right. I didn't know it either until I did pre-calc and calc, and that's where I really getting in trouble. Those last three are so long. So, okay. Real quick. See, it's a work backwards. Recognize the formula. Which one is that? Which one goes sine, cosine, cosine, sine?
Cosine.
Sine, cosine, cosine, sine, sine. Right? So that's sine. So that is sine, now, of what? The pi over 2 and the pi over 3. Now, do I add or subtract the angles in the middle? What is the rule for sine? Same or different? Same. Are we good? Look at the board. Look at the sine. Whatever started, same, right? Cosine is opposite. Right? That sine, cosine, cosine, sine pattern is the sine of two angles. Pattern. That's one sine, two angles subtracting. Now, here's what I want to show you. How do you subtract those guys? How do you subtract pi over 2 and pi over 3? How do you subtract two fractions? Common denom. Top and bottom by 3, top and bottom by 2. So that's the sine of 3 pi over 6 minus 2 pi over 6. That's the sine of 1 pi over 6. Go to the unit circle. It's a half. Done. Good? Everybody see what I did there? Right? Sine, cosine, cosine, sine. That's the sine of two angles added or subtracted. Whatever sine's in the middle, minus, same, minus. Common denominator, boom. Ani.
So my homework sign says sine of 5 pi over 12. Would that mean I just like have to divide everything by?
Okay, what do you mean? You got two angles, right? Sine of 5 pi over 12. What's the other?
Yeah, and then like it's pi over 4.
Yeah, so you're going to make them both common denominator 12.
Yeah, then it's still like 12, and that's on the unit circle.
5 pi over 12 and what?
And pi over 4.
So when you got pi over 12 and cosine
Cosine of pi over 4.
5 pi over 12
Yeah,
and what, pi over 4?
yeah.
Added or subtracted?
Well, it's sine next to cosine. No, I'm talking about like the very beginning, like right there. It says.
I totally understand. What sign do you have right here in the middle?
Oh, it's the same problem. Yeah, it's sine. Well.
Do you have a plus sign here or a
No,
minus sign here?
It's minus. Sorry.
Right, that's okay. So and this would be minus, like that. So then you have to get common denominator. So multiply top and bottom by 3.
Wait, but like, why would you like subtract that though?
Exactly what I just did here.
But if it's
Has to be same.
like right in the beginning, it's before the subtraction happens. Like I'm
You
saying
sure
if
you're
I'm
looking at
trying
number
to-
11? You're looking at number 11?
Yeah, if I'm identifying that on the unit circle, 5 pi over 12 is what I'm talking about.
You don't look there first. So look what I did on it. Follow what I did. I did not immediately go looking for that pi over 2, did I? I first subtracted them, got a result, and then went and looked for that. You go look at the end, not at the beginning. Right? So first I followed the yellow brick road of the pattern. First I took the two angles they gave me and subtracted them. Got an answer, then I went to the unit circle. So you don't go immediately with the 5 pi over 12 to the unit circle. You first subtract them, because that's what this formula says. If you have 4 things, that's one sign, those subtracted.
Okay.
So you do that first. You'll get 2 pi over 12. That reduces to be pi over 6. That's on the unit circle.
Okay.
Yeah, so you go to the unit circle at the end on that. Yeah, that's good. All right, we got. Okay, so number 14. Yeah, this. Let me get a fresh screen on this one. So number 14, cosine. What's it saying? Cosine of A is 15/17. 15/17, and it's in quadrant 4. A is in quadrant 4, and then the second part says sine of B is minus 5/12, quadrant 3. Sine of B, minus 5/12? Yeah, minus 5/12, quadrant 3. Minus 5/12, quadrant 3. Like that, okay. So, here we go. And then what do they want? Basically, if you look what they want cosine of the angles added, sine of the angles added, and tangent. They want the moon. Cosine, sine, and tangent of the angles added. All right, how are we going to do this? This is basically draw the triangles. Remember the ones we just did? Where they give you the quadrants, you draw the triangle, you do the SOHCAHTOA, and you do the Pythag. We got to do that twice. And then put them all together in the new formula and do that whole thing 3 times. And that's one question. That's what's going on. All right, let's do it. So I start here and I go, okay, quadrant 4. So quadrant 4 is here. I'm looking at A's in quadrant 4. So I'm going to put angle A there in quadrant 4. And remember your SOHCAHTOA. SOHCAHTOA. Right? So cosine.
It's adjacent.
Adjacent over hypotenuse. That means this is adjacent. This is hypotenuse, isn't it? So this is adjacent, opposite, hypotenuse. So adjacent is 15. Hypotenuse is 17. Good so far? Remember making these triangles, the same kind of triangles we made before. I just put it where they told me, quadrant 4. Adjacent is 15, hypotenuse is 17. That's cosine. So I got to find the other side. So I'm using SOHCAHTOA. Then how do I find the other side? Pythag, right? So now I do the Pythag, which is a squared plus b squared is c squared. Which one's the c always?
The hypotenuse.
The hypotenuse. So 15 squared. Was it 15? It was 15. 15 squared plus b squared. What's that? 225 plus b squared is 289. Subtract 225. B squared is 64. Root it. B is 8. Bring back the 8. The other side, the opposite side, is 8. Good? Remember all that stuff we did about making triangles in certain quadrants? So we make that triangle. And we just leave that information. We're going to use it in a minute. In fact, let me just let's just go ahead right now. Should we? Yeah, we really should. Well, let's just leave it. Okay, now let's go over here. And now let's do the other triangle. This one's quadrant 3. So I'll put it in quadrant 3. Like that. I'm going to put B in quadrant 3. See where I'm putting it? And do the same thing. We're talking about SOHCAHTOA again. And the Pythag. So sine is opposite over hypotenuse. So this is the opposite side, the hypotenuse, the adjacent side to B, So opposite is 5. Hypotenuse is 12. Good to there. Okay, so now I got to find the missing side. How are we doing? Have I lost yet? We're just doing the triangle thing like we did before. Right? So I just took the sine. And don't worry about the negative. We'll figure out the plus minus based on the all students take calculus. So the sine is 5/12. The sine of beta is 5/12. Opposite hypotenuse. Good. Got to find the other side. Pythag. So a squared plus b squared is c squared. Which one's the c?
12.
The 12. The hypotenuse always. So a squared, so it's a squared plus 5 squared. A squared plus 25 is 144. Subtract 25, a squared is 119. Root it. A is the root of 119. Are we good to there? We good. So we just did double triangle. We're about halfway there. We just did double triangle. Now, notice there's two different angles here, aren't there? Remember, all these formulas we've been dealing with today, sine, cosine, tangent, they're all about two angles. Added or subtracted in one sine or cosine or tangent. And what you do with all that, right? Well, notice what you do. When you have two angles added in one sine or cosine or tangent, it ends up being a bunch of sines and cosines and tangents of those individual angles, doesn't it? So, what does that mean? I need sine, cosine, and tangent of the individual angles. Meaning, let's keep this separation clear in your mind. The left side is all about A, angle A. Started with cosine of angle A, and I got the whole triangle, so I can find the rest of A. And the right side's all about B, started with sine of B, and I got the triangle, so I can find the rest of the facts concerning angle B. So let's find the rest of the facts. I have cosine B. Let's also find sine of, I have cosine A. Let's also find sine of A. You with me? Why? Why am I doing this right now? Because then I'll put them all together to be able to use those formulas. So let's find cosine, sine, and tangent for A. Let's find sine, cosine, and tangent for B. Does that make sense? Well, we have two angles here, A and B. They're different angles, they're different triangles, they're different quadrants. I want to take them now and find sine, cosine, and tangent for A, and sine, cosine, and tangent for B. So I've got cosine for A. They already gave me that silver platter. What's the sine for A? What's sine? SOHCAHTOA? Opposite over hypotenuse. So 8 over 17. Good. What's tangent of A? Opposite over adjacent. TOA. That's 8 over 15. But, what are the signs? How do you know if they're plus or minus or what they are?
What function it is.
Depends where they're at, right? All are positive, students is positive, take positive, calculus positive. So I'm down here in the fourth quadrant. For A, I'm just doing A, I haven't got to B yet. Just for angle A, he's in the fourth quadrant. The fourth quadrant, only cosine's positive. The other ones are negative. So that means sine and tangent are negative. Negative. Watch your signs. Got to get them right. That makes sense? You could have done that by the triangle, because that's over 15 down 8. So that's technically a negative 8. That's why these both came negative, because the 8 is negative. Whichever way you prefer. Is that okay? Is that making sense? This is where I always say my daughters, when I did this with them a couple years ago, they were taking Mr. Jameson for pre-calc, actually, when they did more trig. And anyway, I would do this with them, and I was always telling them the signs, plus minus, and they would go, oh no, Dad, we just like to do all students take calculus. There's too much to worry about with all that. We just check it at the end. So whatever works for you. So you can just make sure they're right at the end if you'd rather not worry about. There's so much to worry about at this point. Get them right at the end, right? I'm in the fourth quadrant, only cosine is positive. These guys have to be negative, don't they? Now, so we've got cosine right here, sine and tangent. We got all three for A, right? Cosine, sine, tangent, all three for A. Good? Let's find all three for B now. We already have sine. They started me with sine. So what do I need? Cosine for B. What's cosine?
Negative.
Adjacent over hypotenuse. So adjacent is, I never wrote it in, did I? It's root of 119. Root of 119. So adjacent over hypotenuse. Root of 1 over hypotenuse, which is 12. Is it positive or negative?
Negative.
Well, yeah, let me get the other one first. Tangent. Tangent of B. What's tangent? TOA. Opposite over adjacent. Opposite 5 over adjacent root 119. Okay, now for the signs. I'm in the third quadrant, aren't I? Third quadrant, all are positive. Students, take tangent. So in the third quadrant, tangent is positive, everybody else is negative. So for B, angle B, third quadrant, tangent is positive. So the tangent is positive, everybody else is negative, cosine and sine are negative. Good? Now I have all the pieces. I'm ready to finish this problem off. Are you ready? So we got all those pieces. Now, what do they want from me with all this? They want to know, for starters, cosine. They want you to add the two angles and find cosine, sine, and tangent. So what you do is all three of those formulas and plug in all the pieces that we just found. So here we go. Cosine of A plus B. So I'm ready. This is number 14, right? It's number 14. They want cosine of A plus B. Now, according to the formula we learned today, what's the cosine of A plus B? It's cosine, cosine, sine, sine, and you put the A, B, A, B, A, B. And what goes in the middle? Does cosine keep the same, plus or minus in the middle, or opposite? Opposite. So if it's plus in here, he does minus. Opposite.
So are we solving them, or are we just writing out the problem?
Now, we'll go get them. Everybody good so far? Everybody got that written out? Now, go get cosine A. Where is it? Cosine A, up here. Here's cosine A, 15/17. All the pieces we need are going to be here. If they say cosine A, there. If they say sine A, we go there. If they say cosine B, we go there. Right? They're all there. We just plug in the four things we need now that we have them all. So cosine A, 15/17. Times cosine B. What's that? Cosine B, right here. Minus root 119 over 12. Right? Am I losing you?
Nope.
Sorry, these are long. That's why I wanted to get here. Minus root 119 over 12. Minus sine A. Let's go get sine A.
Negative 8.
Here it is. Minus 8/17. Minus 8/17. You can put parentheses if it helps. You don't need to. Whatever. Sine B.
Negative 5.
Where is it? Sine B is up here. Minus 5/12. Did you see all that mess? I just went and got all the pieces they wanted, huh? We found them all with the two triangles. All right, let's finish it up here. 17 times 12, 17 times 12. They both have the same denominator. It's common already. What is it? 170 and 204? Is that right? Okay, 204. Okay, so I just did 17 times 12 on the bottom. 17 times 12. And they both have it. See how they have the same denominator? So we don't need two fractions anymore. It's just one big common denominator. What happens on the top? Am I losing you? Hang in there. We're almost done. 15 times negative root 119. That's negative 15 root 119. Positive times negative is negative, right? The 15's an outsider. He stays outside. The 119's an insider. He stays inside. Over here, negative, negative, negative. 3 negatives. What's that going to be? You see what I mean? 1 negative, 2 negatives, 3 negatives. 1 little piggy, 2 little piggies, 3 negatives is going to be negative. 5 times 8, 40. Done.
You only have to do that 2 more times.
And then you got to do sine of A plus B and tangent of A plus B and plug in all those pieces.
Okay,
And that's just one problem.
got it.
Does that make sense, what they're asking you to do? Not good? Requires a lot, doesn't it? Requires almost everything we've learned, that one problem. Doesn't it? Requires SOHCAHTOA, requires Pythagorean theorem, requires drawing triangles, requires what quadrants, requires how the sine, cosine, tangent are positive or negative in which quadrants, requires the new formula of adding, subtracting.
Those better all be on our 3 by half.
Almost all that we've learned in these problems.
We get extra time when we take the test to do something like this?
Hour and 15 minutes.
How many questions?
37. No, 20.
How many of these will be on there?
Whatever the practice time has, probably 2. Probably. I think. Where are we? All right. Well, that was a lot of math.